Welcome to my video on DHCP, Dynamic Host Configuration Protocol. In this video, we're going to be talking about different parts of DHCP and how they work together. The first thing I want to talk about is how DHCP provides IP addresses. There's 4 steps to providing an IP address using DHCP. DORA. There's DHCP Discover, which is when the client broadcasts a request for a DHCP server. DHCP Offer, where DHCP servers on the network offer an address to the client. DHCP Request, the client then broadcasts a request to lease an address from one of the DHCP servers. And finally, DHCP ACK, which stands for Acknowledge. The DHCP server that the client responds to acknowledges the client, assigns it any configured DHCP options, and updates its DHCP database. The client then initializes and binds it to the TCP/IP protocol stack and can begin network communications. Now I want to give you a practical example using a diagram of my network as shown here. So let's say this workstation wants to communicate with the rest of the servers as well as the internet. He needs an IP address in order to communicate with the rest of the network. So he broadcasts a request for a DHCP server. The first server to respond is going to be server 10 because he's the closest. Server 10 will then offer an address to my workstation. Then my workstation broadcasts a request to lease an address from server 10. Server 10 responds, changes all the settings in his DHCP database, and now my workstation can begin communicating on the network. The next thing I want to talk about is providing redundancy for your DHCP. DHCP failover is a new feature available in Windows Server 2012, ensuring continuous availability of DHCP service to clients. With DHCP failover, 2 DHCP servers share scope and lease information, enabling one server to provide DHCP leases to DHCP clients if the other server is unavailable. So, configuring DHCP failover is very important in providing redundancy for your DHCP servers. Now I want to talk about some options that DHCP offers. DHCP servers can be configured to provide optional data that fully configures TCP/IP settings on a client. Some of the most common DHCP option types configured and distributed by the DHCP server during leases include default gateway, router, and DNS parameters. Clients can also be configured with different information options. The types of information options are router, DNS server, DNS domain name, NetBIOS name server, NetBIOS datagram distribution server, NetBIOS node type, and NetBIOS scope ID. Clients can receive these values to set their TCP/IP configurations during the period of the lease. The next type of option is called internal protocol options. The first is lease time. The second, DHCP message type. The next is special option type used to communicate a parameter request list to the DHCP server. Then there's 2 different time values, the renewal time value and the rebind time value. In most cases, the actual values provided to clients with these options are taken from the DHCP service property settings on the DHCP server. The next set of options are options for remote access clients. When a remote access server assigns an IP address to a remote client, either from its own static address pool or from its cached DHCP address pool, there is no effective lease time for the IP address because it's simply released when the client disconnects from the session. However, remote access clients can still receive additional TCP/IP configuration information from the remote access server. These are the options that you can configure for your remote access clients: IP address, DNS server, subnet mask, NetBIOS scope ID, and your node type. Now that we've covered DHCP options, I want to talk about a DHCP relay agent. The relay agent component relays DHCP messages between clients and servers on different IP networks. Because DHCP is a broadcast-based protocol, by default, its packets do not pass through routers. A DHCP relay agent receives any DHCP broadcasts on the subnet and forwards them to the specified IP address on a different subnet. Now I want to talk about rogue servers. A rogue DHCP server is bad news. Basically, it's a server on a network which is not under administrative control of the network staff. It's a network device, usually like a modem or a router, connected to the network by a user who is most likely aware of the consequences and may be knowingly using it for network attacks like man-in-the-middle. Some of these computer viruses or malicious software have been found to set up rogue DHCP servers, especially those classified in the rootkit category. The way it works is as a client connects to the network, both the rogue and legal DHCP server will offer them IP addresses, as well as a default gateway, among other information. If the information provided by the rogue DHCP server differs from the real one, clients accepting those IP addresses will experience network access problems, including speed issues, as well as the inability to reach other hosts because of an incorrect IP network or gateway. Also, if a rogue DHCP is set to provide as the default gateway an IP address of a machine controlled by the misbehaving user, he can sniff out all the traffic sent by other clients to networks, violating network security policies as well as user privacy. VMware or virtual machine software can also act as a rogue DHCP server inadvertently without being run on a client machine joined to a network. The VMware will act as a rogue DHCP server, handing out random IP addresses to clients all over the network. The end result is that large portions of the network are cut off from both the internet and the rest of the domain without any access at all. The best way to stop a rogue DHCP server is intrusion detection systems with appropriate signatures, as well as multi-layer switches, which can be configured to drop packets. One of the most common methods to deal with rogue DHCP servers is called DHCP snooping. DHCP snooping drops DHCP messages from a DHCP server that is not trusted. So if it doesn't recognize the server or the IPs that it's releasing, then it will drop the packets and they'll never get to the client computers. Now I want to talk about two shorter topics. The first one is called DHCP reservations. The way a reservation works is it maps a MAC address to an IP address. MAC addresses are typically hard-coded into network adapters so that anytime a machine with a reserved MAC address requests a lease from the DHCP server, it will always obtain the same IP address. Reservations are really helpful if a machine needs to obtain an IP address from DHCP and the address should not change. The second topic is called exclusions. Basically, an exclusion removes an IP address or range of IP addresses from the pool of addresses that are dynamically given out by the server. The server will not give out excluded addresses. So if you have some servers like I do in my network, I use anything that ends in .20 as an exclusion range because those go on my servers. And exclusions prevent another machine from leasing the same IP address that are on my static IP machines. The final things that I want to talk about are best practices for your DHCP server. One thing is using the 80-20 design rule. What that means is when you're using more than one DHCP server on the same subnet, you get increased fault tolerance for servicing DHCP clients located on the subnet. With two DHCP servers, if one server goes down, the other server can be made to take its place and continue to lease new addresses. So basically on your first server, you're going to have 80% of the addresses, and then on your second, you're going to have 20. Sometimes I do a 50-50 rule, but as far as best practices go, you want to use 80-20. Now I'm just going to touch on the rest of them. One is to use superscopes for multiple DHCP server environments. I have a superscope that goes over my 10.8, 10.9, and 10.10. You also want to deactivate scopes only when removing a scope permanently for service. Use conflict detection on DHCP servers only under unusual circumstances. Reservations should be created on all DHCP servers that can potentially service the reserved client. If you aren't sure, just make the reservation anyway. It won't cause any problems. For service performance, consider that DHCP is pretty disk intensive, and be sure to purchase hardware with optimal disk performance characteristics. Also, keep audit logging enabled for use in troubleshooting so that you can see what went wrong at what time if something goes down. Reduce lease times for DHCP clients that use routing and remote access for dial-up networking. Increase the lease duration of scope leases for large, stable, fixed networks if available address space is plentiful. Integrate DHCP with other services like DNS. Also, use either routers that are capable of relaying boot P and DHCP message traffic, or use relay agents and set appropriate timers to prevent undesired forwarding and relay of messages. Finally, for DNS with dynamic updates performed by the DHCP server, just use the default client preference settings. That is all I have for this video. Thank you so much for watching, and I hope to see you next time.